Taylor series. All right, if you can understand the meme, you've been to class a little bit.
Ow.
Does anyone get it?
Yeah, I do. This one requires a
Yeah.
high level of intellect to understand, I believe. Good thing me and Sean get it. Yeah. I don't know what Sam means.
Oh, that's so funny.
All right. Sam's here, Rashad's here, Kat's here, Millie's here. All right. So now that we've done the meme, I want you to tell me how much the bowl of coins weighs.
What's the weight?
Oh.
Are they all pennies?
That'd be awesome.
No.
How was the bucket?
Okay, well that's not very
I don't know, bud. That's all that is all the information I have. I feel like y'all think I like talk to this person. Like
see like how tall it is.
Number weight on my head.
it's probably like a Pyrex bowl.
65.
I will tell you the unit is pounds.
Holy
In pounds.
Three.
All right,
Five.
Sean. Anyone else?
42 pounds.
Over my head.
Noah. Your name is not Noah. 13.5.
Well,
11 flat. All right, Michaela.
Dang, I was gonna say 11.
Jenna.
12.6.
Emery. 6. Charlotte.
I don't like that.
27.9.
11.5. 13.7. Oh, of course.
8.5.
I respect your grind.
All right.
I know. I have 13.6.
Everyone ready? I don't have anything to click on. I just found this picture in my notes from last year, but I had the answer written down. I'm gonna write it real big. Ready?
Oh.
Ow.
Oh.
Okay.
Second one, let's go. Second go.
All right. So now, before we get started, we're gonna do this twice today. But we're doing a lot of notes today, so I want to take a couple of seconds to get you moving around, doing stuff. So I'm gonna give you 2 minutes. In that 2 minutes, I want you to find something to share out to the class that you have learned in Unit 9. It can be big, it can be small, but it has to be calculus. We are going to do that thing where we stand up until you say something that impresses me and sit down. We're going table by table, so don't.
Oh, no.
It's all right. So I need you to find something, but I would recommend having a couple of things. Anything from Unit 9 so far. So that's Taylor series, Taylor polynomials, interval of convergence. You have, actually, I'll give you 3 minutes. You have 3 minutes to find a couple of things to be able to share, and then we're going to share out. You have 3 minutes to find some things. They're called interval of convergence. All right, it should be something about Taylor series, Taylor polynomials, interval of convergence. It should be high level calculus. Could be. Are you guys all ready already?
I'm ready. Me too. Our whole table's ready.
Oh wow. Wow. Wow.
Oh,
I think I'm gonna subtract a minute because you guys are relatively ready. Let's see who can impress me the most. You guys are just all silent. You all are ready? Should we go person by person? That's a lot of things. It's also a lot of time. Yeah. You just can't repeat anything. All right, are we ready? When your table is ready, you can stand up.
Our table is never going to be ready.
All right.
Rashad is my table.
Since you asked nicely, Noah, and your whole table is standing, Noah, what does your table have to share about Taylor series or Taylor polynomial? McLaurin is when the center is 0. If you're wondering why the meme was funny, that was it. All right, cool. Sam, what do you got?
Foreign series for sine of x.
Ooh, all right, sine x alternates. A small notice, but it does. Michaela. Okay, so we've got some interval and radius of convergence stuff. Radius of convergence only at center is radius is 0. All right, Victoria. Ooh, that's a good reminder. So this is fourth derivative. That's helpful for notation. Chris, what you got?
So then the unique feature of the Maclaurin spatial cosine is that it's the derivative.
Okay, so we found out we could take derivatives of Maclaurin series, so that's how we got this guy. All right, Nina.
Okay. Maclaurin series for cosine of x also alternates, but it alternates with even exponents and even number of factorials.
Cool. All right, Kat, you're at kind of a disadvantage here. Do you have anything to share? So we see x minus our center in the terms. Excellent. Cool. Thank you for sharing. Does anyone else have anything they'd like to share out? You told me about two of the ones. Does anyone want to tell me anything else about sine of x and its powers, like Nina said? All right, these are the odd powers. What about e to the x? Anyone remember? You're going to have them memorized by the end of today. I can guarantee it. All right, power same as factorial. That's pretty much all of our power series. Same as factorial. Do they do even, odd? All, yeah. Got all. All right. A good reminder of things. So what we're going to do today, we're going to do definitely the rest of the 9.3 notes, and we're going to try to start 9.4 a little bit. We are not going to have problems that time today, but I'm trying to build up as much as I can for next time. So what we're going to do is kind of like we were doing before. We're going to build off of these 3 power series. Again, these 3 plus one more in the 9.4 notes are ones we're going to be building off of to create new series so that we never have to do this process again, because this process of just taking derivatives and trying to find a pattern, kind of annoying. So let's start. This one we did before. We had sine of x and we kind of built off of that. Just a reminder for kind of how we were writing things down. We were usually just listing out the first 4 non-zero terms because of the directions, writing our general term. But it was helpful to write the elementary power series we were working with, sine, cosine, or e, and then doing whatever we were doing to it. So what elementary power series do you see in g of x equals x cosine of x? Cosine of x. All right. Let's write it out. What's it start with? Nina told me it was evens, but what does it start with? No. 1. All right. You guys reminded me that it alternates. So what's the next term? Minus x squared. What's the next term? No. What's the next term? X to the 6 over 6 factorial. Now, that's the first 4 non-zero terms. So I'm going to give myself some space between that and the general term. Notationally, what am I going to write down? All right. Plus dot, 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 and go into the plus. Anyone remember what the general term looks like? Okay. We've got -1 to the n to represent that alternating behavior. I remember I had x to some power and the same thing factorial in the bottom. How do I write out like even numbers? Yeah, 2n, full stop. Think 2 times the number is even. Now, there is a problem with my notation. What is it? I need the plus dot, dot, dot at the end. That's really important because we are claiming equality here. That equality, that equal sign is only true if I have infinitely many terms. All right, so let's look at what happened to cosine of x in our g of x function. What did we do to it? I multiplied it by x. Now, what kind of thing would you hope I could do to these terms with that x? That's kind of a weird question. What? Yeah, we kind of wish we would just kind of be able to like infinitely distribute an x to all of them, right? Wish granted. That's what we get to do. Remember, these are built for bravery. So we're going to start with the first 4 terms, just multiplying each of them by x. And then we're going to make our way to that general term. Easiest one to start. What's 1 times x? Wow, you guys are brilliant. All right. What about the next term? What's that gonna look like when I multiply by x? All right, x cubed, and then the factorial is not going to change, right? That doesn't have any x's in it, so we'll keep it that way. All right, what about the next term? What? Guys, new fun fact: 4 plus 1 is 7. All right, 4 factorial. All right, save that 7 though, because what's the next term? X to the power of 7 over 6 factorial. All right, so our first 4 terms already done. We're working on the general term. Now, is that -1 to the n going to change at all? No, our alternating behavior didn't get changed by multiplying by x. I noticed something else did not change at all. Yeah, the bottom, that factorial on the bottom, we're still using those even numbers. My question, how do I fix the x's? What will the new exponent be? 2n plus 1. You can think of that if you would like. X to the 2n times x to the first, we would add those exponents together. So that does make a lot of sense as far as what I would need to be doing. I'll keep my plus dot, dot, dot for the end. Not too bad, right?
Why is it plus dot dot dot? Why is it just
For here.
with the middle bit?
Yeah, so you're kind of, the dot, dot, dot is like the other terms, but they're still being kind of added on either side. So this is just representing the like all the terms in between.
Oh.
In my head, that's at least why I would say it that way. Yeah, so this is, I'm adding infinitely more stuff. All right. Yeah, that's actually where we do stop because we have the first 4 non-zero terms, so none of those became 0. That's fine. I have the general term. You do want to make sure in your general term that you only have 1 x there to kind of 1 power, but that's it. So now we're going to, the 4 in the example we did to finish last class, we took a derivative of the series that we got. So you guessed it, we're going to integrate. Now, you're not really going to like the way I do this question, so I'm going to give you a shortcut afterwards, but I'll show you with good notation what I should be doing here, and then kind of a way to shortcut that notation because it's going to feel a little silly. One thing you might be noticing is that inside the integral, we're not using the letter x, we're using the letter t, and that's because the x is up in our bound. So when I start integrating term by term, I'm going to be using the letter t in my terms, and I'm going to take x for when I plug in my bounds. All right, you guys ready? You guys look tired today. Today's been rough.
Like I walked through the school and I was like, it's not gonna be an all. I had a great day.
I'm trying to like manifest a good day because I had a really bad day yesterday. Try. It's not going too bad. So. All right, let's start integrating. So this problem, get ready, is going to be integrate. So I'm going to integrate term by term. Now, peeking down towards the end of this piece of paper, this is the end of this problem. So if you think I am going to simplify any of these terms, you have not been here all year. So I'm going to go term by term, just leaving everything super gross because this is the end of my problem. So let's start. We're building our bravery. We're starting by integrating x. What is the integral of x? 1/2 x squared. Now, I am going to use t again because this has t's in the integral. And personally, we've been putting like a lot of the stuff in the denominator. So I'm going to go t squared over 2. If you wanted to write 1/2 t squared, those are equivalent. You do you. All right, for the next term, I'm going to just keep the 2 factorial chilling in the bottom of my denominator. And I'm going to, looks like you guys were raising powers by 1 and dividing by new powers because that's how we integrate. So x cubed, what's he going to do? X to the 4th. And like the divided by 2 for the 1/2 that Emery said, I'm going to divide by 4.
Why is it extra?
What?
Why is it extra?
Because I made a mistake and I should be writing T. Thank you. Made a big deal about it, then forgot. Yeah, so you could anything that's equivalent you can write. A lot of Taylor shoes just get written with all the constants in the denominator. Yeah. Yeah. You could simplify it if you want. I just don't feel like it. Yeah, so you could put 8 on the bottom if you wanted to. All right, next term. Again, I'm going to keep the 4 factorial here. What's the rest of it going to look like? T to the what power? 6. So who's going to join the 4 factorial? Wow. All right, we got this. Got it now? All right. Oh, wait. Did I skip one? No. 2, 4, 6. All right. Oh, 6. Wow. Too much stuff up there. All right. Keeping the 6 factorial. What's the rest of it going to look like?
T to the 8.
T to the 8th. All right. So I think I've kind of got this pattern down. Now I'm going to try to write my general term. Anything that's going to stay the same in the general term that didn't really get affected by this integral. Okay, the alternating, so I'll keep -1 to the end. What else kind of stayed the same? What about the denominator? Because there's new stuff. The factorial's the same, so I'm going to keep that on the back end. There is new stuff popping up, though. So let's try to figure out, it looks like the power and the number on the division are both the same. So how did we get that new power? We added 1, right? So if the power was 2n plus 1, 2n plus 2. Now, the beauty of these is you can try to do this by like pattern making too. So if you think your first term in this usually is n equals 0, so you could try to figure out, well, how can I get n equals 0 to be 2, n equals 1 to be 4, n equals 2 to be 6 and try to make a kind of formula for that, or you can just kind of algebraically manipulate. Thank you. Y'all, my brain is also tired. All right, what else am I missing? Plus dot dot dot. I'm actually missing something else based on the integral. Not plus c. We had bounds. So we're going to do the vertical bar and 0 to x. Now, this next step is the part that you're not really going to like because I'm about to plug in the bounds. What is the x bound going to do? Yeah, it's going to replace the t's with x's. So I'm essentially going to just plug in x everywhere I see a t. When I subtract, I'll be plugging 0 in for all of those t's. It's infinitely many terms, but it's going to be infinitely many of what number? 0. So really, when I plug in these bounds, all I'm doing is I'm just replacing the t's with x's. So let's write that down, and then I'm going to talk about how you can shortcut that because it feels stupid, personally, to write all of this. And the reason I kept writing x's is because I was trying to do that shortcut in my head. My brain was fighting with me.
Easier to do like 8 factorial. Just like x
What?
over 8 factorial. Isn't that easy?
This, you can't do 8 factorial. You could do the number 8 because that's 4 times 2 versus 8 factorial would be 8 times 7 times 6 times 4 times 3 times 2 times 1. So you would have to do the 2 factorial and then multiply by the 4.
So we should
You can't like combo the factorials the way you want to. Ma'am.
I always get like confused with how we know what's right on the bottom.
What?
Like, how do we like know what's the right?
Of this guy?
Yeah. Or like for like.
So I start with what I had up here. So since I'm manipulating this guy, I'm starting all the factorials on the bottom are going to kind of stay on the bottom because they don't have anything to do with x right now. So the other stuff that I'm putting on the bottom has to do with me integrating the terms. So like this is technically 1/4 x to the 4th from me integrating x cubed. I'm just choosing, instead of writing 1/4, I'm choosing to divide by 4 in the denominator. I feel like I didn't answer your question. If you can you think of a different way to phrase it? So maybe I would be able to. If you need to. Okay, if it comes up again, please, I want to answer your question. All right, so if this 2-step process felt a little silly to you, here is an option. I am okay if you go from here to here if you check the bottom bound. What I mean by that is we were able to just plug in that x because when I plugged in 0, all of the terms were going to be 0. There are a few instances where I could get something that could potentially be something that's not 0. It would have to be a really special situation, though, because you're adding up infinitely many terms. We only know 2 series where we can sum them up. Do you remember those 2 series from your Unit 8, the types that we could actually find the sum? Geometric and telescoping. The odds that this kind of power series is going to make something geometric or telescoping after I've done all this manipulation, really, really low. You could have a situation, I'm trying to even think what it could be, where like you could plug in, there might be something left over. So just make sure you check the bottom bound. But if you want to skip all the step with the t's, as long as you are mentally checking for that bottom bound, I'm good if you just do x's. All right, the last 2 problem. Oh wait, these ones are cute. So I'm going to do a cute problem. You're going to do a cute problem. We're going to do a long problem. Then we're going to take a solid break. These are adorable. So have you ever wanted to use an infinitely long polynomial to find a limit instead of doing L'Hopital's rule? To be fair, this one would require 3 rounds of L'Hopital. The way we're going to do it is a little bit cuter. So we're going to just find a fancy way to do this. So do you see one of our elementary power series? sign. I like these a lot, so you might see one of these again. Because I get to pick the questions.
You might.
What? What? You gotta wait and just preface it. I think it's really cute. It's cute. All right. So how does sine of x start? I want to write the first four terms. All right, x, because we have odds.
X cubed over 3 factorial.
Nina can read. What's the next one?
Plus x to the 7. Which is 5 factorial.
Darn it! Don't curse in my classroom. Oh, that is not what I heard of here.
I said I'm damaged from that.
All right. Now, I'm not writing the general term here because the answer to a limit is usually a number, right? So I'm betting that if I have this first four set of terms, that I can probably work my way through the end of this question. I don't think I'm going to need to go all the way out to the nth term because eventually I'm going to be plugging in x equals 0. So what I want to do now is I want to figure out how I can build up to this guy. So I'm going to ask kind of a vague question, hoping for a specific answer. What happened first to this sine of x in this limit? I subtracted x, right? So I'm going to do sine of x minus x. Now, when I subtract something, I don't like distribute subtraction the way I distribute multiplication, right? So subtracting x, what's it going to do to this big long series? Yeah, it's just going to kill off the first term. So I'm going to still be left with negative x cubed over 3 factorial, x to the 5th over 5 factorial, x to the 7th over 7 factorial. Cute. We subtracted it. All right. What happened next? I divided by x cubed, right? Now, when we divide, that's like multiplying. So I'm going to do this to every single term here. So let's start with the easiest one. What is negative x cubed over 3 factorial divided by x cubed? Negative 1 over 3 factorial. Because I divided it by x cubed. All right. I'm going to divide the next one. What's x to the 5th over 5 factorial divided by x cubed? X to the 7th over 7 factorial? Oops, that's not 4 factorial. What am I doing? All right, what's the last thing that happened in this problem? The limit. Here's the cute part. All right, so the first term is just a number, right? So when we take the limit of a number, we get that number. What about x squared over 5 factorial? I'm plugging in x equals 0. What's that term? 0. What's the next term? All right, I know we don't have it written down, but what's the next term? You guys see the pattern? X's. I'm plugging in x equals 0, doing direct substitution. Is every single other term after this going to be 0? So I get an answer, negative 1/6. I think it's kind of cute. Thank you. All right, you guys are going to try the next one. And while I do that, it was requested in my other class to see what this would look like with L'Hopital, just because they were like, I bet that's easier. So I'm going to write up the L'Hopital steps off to the side so you can see how not cute it is compared to this. So can you guys try in the next like 4 minutes? I bet you can do it in 4. Try the e to the x problem. And we are almost at our break. No.
I left like my pencil and things down in my last class.
Go ahead. think it's very cute.
Yeah, I like Lobie's all better. I like this.
Better way.
It's possible.
You guys reminded me about a couple of things. What? Where?
I don't know what to get.
Oh my gosh.
How?
Did you say add? Does it mean, not like actually add, like, in the bottom, I thought you were doing so 2 times 2. Yeah, thank you for making that word add. That was
The answer is do it one time, but I do 2 times.
Yes.
I got one half.
To the X minus 1.
You don't subtract one every time. Yeah.
I got one half.
One half. That's my answer.
Yep, and then you're gonna. So I get rid of one, yeah.
Well, I don't think I would do Sammy.
You're looking at
Yeah, but you can simplify it.
2 times 2 factorial.
I wasn't sure.
Hello, so like that. Yeah. Okay. And then for plugging it back or plugging like the 0 in.
So you're just going to plug 0 into all of these x's. I would
Okay.
argue that only one thing is going to not be 0.
Okay, the 1/2.
Mhm.
Okay. Thank you.
Mm-hmm. Yeah. Ah!
Square over 2x. You can't do anything.
All right, most of you guys got this right, so I am just recording our process. All right, x minus 1 over 2x. 1/2 plus. Now, a couple of you were asking how to write the denominators. You could certainly write these like we did in the last step of like 2 times 2 factorial. You could also simplify them, whatever you want, either one. X squared over 3 factorial is 6 times 2, 12. Last thing was our limit. What'd you guys get for your answer? 1/2, because we have 1/2 for our first term. All the rest of the terms will be 0. So just a kind of cute way to use Taylor series to do something. It's kind of cool because like for the first one, you would have to use 3 rounds of L'Hopital to get to your final answer. So kind of a cuter way to get there than before. Or maybe even if you have your Taylor series memorized, could be like an easier way to get there, depending on your idea. All right, I want to get the next 2 problems that we're going to be doing are the ones that are going to take the most time today. So I'd like to do one before break and one after break just to kind of separate so our brains don't literally melt out of our heads. These last 2 are when I'm going to be multiplying or dividing by a series, but with another series. So this turns into a much larger problem because I'm either multiplying 2 things that have infinitely many terms together, so doing like an infinite FOIL, or dividing. And you can probably guess how we're going to divide based on the fact that I think it's going to be a difficult problem for you guys. Cough, cough, hint, hint, long division. So we'll save long division for after our break. Does anyone notice something? This is a vague question, so trying to see if you notice. Does anyone notice something kind of different about these directions here? First three non-zero terms, and they're definitely not asking me for a general term, and they will not because this is going to get way too complicated for us. When we're multiplying, we can't just multiply two general terms together. There's going to be a lot of combining like terms here. So do you guys remember what e to the x was, how I could write it out? We're going to use, I think, 4 terms, and I'll explain, or no, I'm going to use out to the 4th power, and I'll explain why in a second. What's the first term of e to the x? Next one? No. X. Next one? Next one? All right, and I'm going to go out to x to the 4th power. The reason I'm doing that, I need to find the first 3 non-zero terms. So that could mean that I'm doing the constant term, like the 1, the x squared. I'm giving myself a little bit of buffer. So really what I'm trying to avoid is having to go back and kind of restart the problem and add in more terms. So I'm going out to x to the 4th just in case there's 1 or maybe even 2 terms that are 0 so that I don't have to go back and restart my work. Cool. All right, cosine. We're also going to go out to the 4th power. So I'm going to start with 1 and then minus my evens. I'm starting to lag. I'm getting so scared. Now I'm doing minus ... here. You don't necessarily have to, but that was just the way the alternating worked. So if you see me doing minus ... that's just because the next term was going to be subtracted. All right, now in the next step, we're going to be multiplying these together. So we really kind of want to have a simplified version of this. So I'm actually going to multiply out the factorials in the bottom so that I can work with them. So here is my first guy, x squared over 2 factorial. 2 factorial is 2, so I'm going to go ahead and do that actual 2. X cubed over 3 factorial. What is 3 factorial? All right. X to the 4th over 4 factorial is? All right, going to do the same over here. X squared over 2, x to the 4th over, what was that, 24. All right. So really we're going to start distributing and kind of organizing to combine like terms. I personally have a way that I like to organize this where I'm going to kind of do one distribution and then kind of line up my like terms vertically as I do more distribution. So this is my preferred way of organizing this. You can certainly organize a different way. Sean? Generally 3. I would, if you did more or less, I don't think they would care as long as you're not just like doing 1. No. All right. So I would like to color code these. What's your favorite color? Red. All right. So because cosine has less terms, I'm going to distribute from this side through here. This is actually pink. I lied. All right. So I'm going to distribute like this. Now I'm distributing 1, so that's not too bad. So I'm going to have 1 plus x squared over 2 plus x cubed over 6 plus x to the 4th over 24. Yeah, this problem is a lot. This was a couple of years ago. This type of problem was like part D on the free response of the Taylor series. Part Ds are usually like really hard. Like those are the ones that a lot of people aren't getting the answer correct. What goes well with pink? Green. I agree. All right. Now I'm going to be rolling through with the x squared over 2. So let me do a little pointing to help. So now we're going to take negative x squared over 2, and we're going to distribute it starting with the 1. Negative x squared over 2 times 1 is just negative x squared over 2. But when I write it down, I'm going to write it here. I didn't. I just didn't feel like drawing all of my arrows. Sorry. All right. So I am distributing here. Now notice I'm lining up my like terms kind of vertically because I'm eventually just going to add all the like terms down. But since there's so many terms, just so I don't miss anything, you could put these all out in one line. I'm just trying to be a little bit more organized. All right, so I have the negative x squared over 2 times the 1. Now I'm doing negative x squared over 2 times the x. What's that going to look like? Cubed over 2. All right, negative x squared over 2 times positive x squared over 2. All right, x squared times x squared, x to the 4th, 2 times 2, 4. All right, again, I don't really need to keep distributing that because I'm figuring probably by the 4th power I have enough terms to go. All right, last thing, I'm distributing what goes well with pink and green. Ooh, I like light blue better. All right, I'm going to take that x to the 4th over 24. I'm literally just going to distribute it to the 1. So I'm going to do plus x to the 4th over 24. Now I'm going to look to combine like terms. So I've kind of gathered everything up that could possibly be up to the x to the 4th power. So I didn't do all the rest of the terms because I'm figuring I only need to find the first 3 non-zero ones, right? So I know, looking at this, that that's probably going to be the constant term, the linear term, meaning just x to the 1st power, x squared, and then maybe if 1 or 2 of those are 0, I could possibly go up to x cubed or x to the 4th. So I'm collecting everything that I think could possibly be up to x to the 4th power in the hopes that I'll get 3 non-zero terms out of that. So let's see if we do. I'm going to kind of combine like terms down. Will I have a constant term in here, a number? Yes, I'm going to have the 1. I have an x to the 1st power. Yeah, I just have that x. Will I have a term that has x squared in it? No. These are actually going to cancel out, so I don't get to use that. So I'm glad I went past my x squareds as I was doing my work. Will I have an x cubed power? Yes. Hardest question probably of the day. What will the coefficient on it be? So 1/6 minus 1/2. I'm going to give you a couple of seconds to think about it. All right. This is negative 2/6, which is equivalent to negative 1/3. So I've got minus x cubed over 3. Do I need to continue? No. I have 3 non-zero terms in my series. So these guys right here were kind of extra, but I'd rather have more terms than not have enough and have to go back and start all over. Nazi, what's up? What? Yeah, take it from here to here. Yeah. All right. So we're going to take a break. When we come back, long division. Forever. Let's take 5. What? We've used it when we integrated before. Trying to think of other times we've used it. Could have eaten my lunch at lunchtime. What was I thinking? I was just thinking. Nice. Oh, someone remembers integration by parts by saying ultraviolet voodoo. Hate that. You ready? We can do it. What? Oh, no, not. All right. Sine of x. Tell me about it. Sine of x. What does it start with? I. So x. Next term.
Plus x to the five.
All right, I'm gonna tell you that 3 terms is gonna work here, and it's much easier to like add on a term if we need to for long division because you just are dividing. So super not super easier, but much easier to add on another term if we need to. Yeah. So in general, my default is usually 4, just because with the AP test always saying give 4 non-zero terms. This one, I know 3 is going to work personally, but thinking of how long division works, when you kind of bring that last term down, it would be much easier to kind of add in that 4th term if I need it here, than it would be to like add it in for that distribution because you're kind of just the moving pieces. So default to 4. You can try to get away with fewer, especially these ones we're doing 3 non-zero terms. So I'm just hoping that it'll work out. All right. Cosine. Thoughts on it?
1.
Yep. Is anyone starting to get a vibe that these questions aren't horrific? They just require a lot of writing.
Yeah.
Yeah. So a lot of the questions that get brought up about this will give you specific, like they'll make you make a series, kind of like I did up here, and then they'll ask you to do something with it. So the one that was like this multiplying one, they made you make a function and they called it f of x, and they were like, now find the Taylor series for like e to the x times f of x. So it was something you knew. Yes. So they might make you make something like f of x and say, now find f of x divided by cosine of x. So they would be pretty explicit with what you're trying to do. All right. So I'm going to, again, simplify these as we're writing them down. Anyone know which one goes here? Yeah, the sine x one. So I'm going to go x minus x cubed, and I'm not going to write 3 factorial because I need to do a little bit more math here. 3 factorial is 6. X to the 5th. 5 factorial. We haven't done that one yet. 24 times 5, if you'd like. All right. This is 1 minus x squared over 2 plus x to the 4th over 24. A reminder, this one is kind of the driver for all of my choices here. So I'm always going to do what times 1 gets me the thing I want. That's really convenient because 1 is really easy to multiply by. All right, so first box here. What goes here? All right, x, because x times 1 gets me x. So x times 1 gets me x. Sorry for rolling all around. Now I'm distributing the x to the rest of the terms as I go down. So x times negative x squared over 2 is going to be negative x cubed over 2. X times x to the 4th over 24 is now going to be x to the 5th over 24. Now, with your permission, I would like to be our fraction adder and subtractor. Do I have your permission to do that? Speaking of add or subtract, what do I do down? I subtract. Okay. These x's cancel though, right? All right. If they don't, you did it wrong. Okay. Now I am doing the math of negative 1/6 plus a half. It's kind of the same as the other one. It was negative 1/3 before, so it's 1/3 now. We're doing x cubed over 3. So we're doing this time the 1/2 is the positive one. So 1/2 minus the 6, 3/6 minus the 6, 2/6, 1/3. Fractions. What things would we be subtracting in the next one? We'd be doing 1/120th minus 1/24. It is going to be negative, and it's going to be x to the 5th over 30. All right. The adding and subtracting of the fractions isn't really the important part here, so I just want to not crush ourselves on that. What goes in the green blob? What goes in? X cubed over 3. We want to know what times 1 gets me the first thing here. Because we're about to take x cubed over 3 and do x cubed over 3 times 1 and x cubed over 3 times negative x squared over 2. What is that? X cubed over 3 times negative x squared over 2. All right, what do I do going down? Okay. I said I was going to add and subtract the fractions, not multiply them, to be fair. All right. These cancel. If they don't, you did it wrong. All right. Input your numbers into me, the calculator. What 2 things am I subtracting or adding? All right. I'm going to summarize what I think I heard. Negative 1/30 plus a 6. All right. That would be negative a 30th plus a 6. That's going to be what? 4 over 30 or 2 over 15? Yeah. All right. Now I'm actually pretty excited because I'm going to be done after this next step. All right. What goes in the pink blob? All right. Plus 2x to the 5th over 15. Now, am I going to have to go and multiply that through to know that worked? No, I'm confident if I put 2x to the 5th over 15 times 1, that's going to cancel. I don't need any more terms because I needed 3 non-zero ones. So this guy is my answer. Yeah. All right, before we go to 9.4, I promised you 2 rounds of stand and impress me. So take anything from 9.3 specifically. I want you to have a couple of ideas. I'm going to pass out the 9.4 notes while you are coming up with your ideas, and we're going to do a stand and share out again.
I'm standing in
Where did that 30 come from? Which one where that 30 came from? We can talk. Still mad. That 30. That 30 makes sense.
All right, are you guys ready? Are you ready? You ready? You can go first this time. She's by herself. All right, I will get started as soon as we are standing.
I have to take a physics test next class.
You gotta get limber. You gotta get loose. All right, the last part of this next. Oh, we have more time than my other class did. Oh, that's because my computer disconnected 3 times in a row. It's worse. All right, Gribbon, get your table in order. Get your table in order. What are you doing? Are you protesting? Stand up. Sean, go. Sam, go. All right, Kat, since you asked nicely, what is your share? Nice. We can use a cute McLaurin series to go around L'Hopital if you want. You can sit. Jillian.
Okay, so the 4 and 4 sine x, e to the x, and cosine
Ooh, nice. Domain, all real numbers, interval of convergence, everywhere. That works. Chris, what do you got?
So then from where I started making notes, these three functions, we consider them as elementary functions, which we can base off almost of these problems.
Cool. We are going to memorize sine, cosine, and e so we can build off of them. There are elementary power series. Emery, what do you got? Nice. So a lot of these things that we're doing, we go term by term, taking derivative, integral, all of that stuff. Elena.
That sounds good.
Nice. We can kind of go around plugging in that 0 if we can. All right, we got 2 tables left. Oh, wait. And Nina. Any ideas? Any ideas? What? What about the sine is greater than the cosine? What do you mean? Okay, so, okay. Can you remind me just one more time going off of that? Which one has the evens? Which one has the odds? Sine has odds, cosine has evens. All right, my last group.
When there's a division bar, you can do long division.
Okay, when I could do division with my Taylor series, and that was long division. All right, so I believe if we can focus for a couple of seconds, I may be able to end a little earlier than I did in my other class. So I'm going to just do what I did in my other class, and if we get done with that a little bit earlier, I will stop talking, I promise. I would like to just take a moment to say I appreciate you. I know it doesn't feel like it because I'm putting a lot of information in your brain today. Remember our goal. We're trying to get problem set time next time. So let's do this thing. Oh. All right. Can anyone find a word they know at the top of the notes? Geometric series. That was the vaguest question, and you gave me the exact answer I wanted. Beautiful. So, the last series we are going to have memorized is based on the geometric series. So what we're going to do, we're going to build up to that idea by reminding ourselves some things about the geometric series. So we're going to go back to a series of constants for a second. Then we're going to roll to a power series, meaning it's going to have x's in it. So let's suppose that my first term, my a of my series, is 2. And let's also know that, what did R usually stand for? The ratio. All right, I'm going to do what we usually do. I'm going to try to write 4 non-zero terms and then a spicy general term. So what is the first term?
2.
Wow. A little bit harder. What's the next term?
Give it a second.
2/3. Why is it 2/3? 2 times 1/3. All right. What's the next term? All right. 2/9. Why? 2/3 times 1/3. Multiply across the top and across the bottom. Thank you for not getting stumped like my second block did.
Yeah, why are they just not as
What? Oh, this? The like Microsoft Word math type does that if it's like in line with anything else, and I couldn't fix it and it was driving me nuts. The worst. All right, are we ready? We don't sound ready. What's the next term? All right, now we need to think about the general term. Do you guys remember when we were looking in Unit 8 for the like series term for geometric? What did it normally have in it that made us think, oh, this is geometric?
And
Yeah, like something to the n power. And what usually went to the n power? The ratio. So I'm going to put this inside here. What does it feel like we're missing though? Yeah, I'm kind of missing all the 2's, right? So I'm going to roll and put this 2 here. This works as a formula for this if I start at n equals 0, because there will be no 1/3 in the first term. Negative 1/3 to the 0 would give me that, just that 2. Now, what I would like to do is I would like to try to find the sum of this series. Do you guys remember our sum formula? All right, so for this guy, I would see what? 2 over 1 minus 1/3, right? Cool. All right, let's change this slightly. You could simplify it if you want. Not really the point right now. Yep, and that works because we're usually starting at n equals 0. Here it doesn't really matter since I'm listing out the terms instead of using like the index. All right, so what did I change for the next what if question? The ratio, it's now negative. What's that going to do to the terms? There's a cool word. It's going to make them alternate. So I have 2 minus 2 over 3 plus 2 over 9 minus 2 over 27. Sorry, I got distracted.
how far did you go the other way?
I did this and then one more problem. All right. I'm going to still write this like a geometric using the ratio right here. But what is this going to do to the sum formula? Yeah, the R on the bottom will make that like a plus. So we're going to have 1 plus 1/3 in the bottom. Now, in terms of Unit 9, that's not Unit 9 stuff. In Unit 9, we have been putting X's in our series. We've been making these a power series where I have more than just a series of numbers. So let's call our first term 1 and our ratio X. What would my first term be? Cool, just told you that. What would the next term be? What would the next term be? The next term? The general term. X to the n. That works if we're starting at n equals 0, which is generally where we start series. What would the sum look like? Cool. This is actually the only other power series that we're going to want to know about. It represents actually how we can build off of this is pretty exciting because we get a whole new class of functions from this. Does anyone know what functions that look like this look like fractions, like a bigger name for those type of functions? Starts with the letter R. Rational functions. Algebra 2 is actually learning all about rational functions right now. But you can imagine that if I'm able to multiply, if I'm able to substitute, if I'm able to do all of these things, this can be a really exciting series to work with because I can now make a ton of different rational functions into infinitely long polynomials. So I'm literally going to show you one example of this just to get the idea in your brain of how to do this. And then we're going to come back next class and practice more with this idea. So I'm going to go past this next page and we're going to go to the one at the top of the next page. I want to write a set of directions really quickly. They're not going to make a whole lot of sense while we write them down, but will you just write them down for me for a second? So I'm going to rewrite the sum formula. And these are our 3 directions. Change the center. Make the 1. Make the minus. So write those down real quick, and then I will explain what we're doing. the number 1. Sorry, I didn't want you to think it was like an L. So what we're going to try to do, if we're given a rational function, we're going to try to make it look like something as A over 1 minus something as the ratio. You can see right now the question we have is 12 over 4 plus x. That doesn't look like A over 1 minus r. So I'm going to try to make 12 over 4 plus x look like this sum. I'm not going to have to do it in this question. We'll talk about changing the center next time. We're going to focus on steps 2 and 3 for this one because this one's centered at 0. If I remember for the center, usually we see like x minus a number. If it's 0, I just have x and x is currently by itself. So I'm going to ask you some weird questions. Hopefully you'll answer the way I want. If you don't, I'll ask different questions per usual. So, you ready? Last question of the day. I promise I'll stop melting your brains. All right, so we don't have to change the center because x is currently by itself. So the next step is to make the 1. So I'm focused on this 4 right here. 4 is not 1. I need a way to make it 1. Divide by 4 is how I want to do it. Now I could add or subtract, but that would cause a problem because I changed the center at the end. So we'll see what that looks like next time. But I'm going to divide by 4. So let's divide everything by 4, or think of multiplying by 1/4 on top and bottom, if you like that. On the top, I've got 3. This is now 1, like I want it to be, and plus x over 4. Now, I don't want to do anything else to this question to change that 1, because in the sum formula, I need a 1 there. The next thing, and kind of last thing I have to do, is make the minus. So what could I do to that 1 plus x over 4 to make it a minus? Okay, an option would be to multiply by -1, but that would mess with the 1 that I just made. So can you think of a different way to make that a minus? Okay, I could think about making it, instead of adding, isn't adding the same as subtracting a negative number? So let's see if this is true. Could I do 1 minus negative x over 4? Is that the same? Cool. Once I have the 1 minus in the bottom, and we'll talk about changing the center next time, I can now identify A and I can identify R. So we're going to write out the first 4 terms and the general term. It's a little harder because I didn't explicitly tell you this time, but what's the first term of this series? 3. It's the A in the top. All right. What is the ratio? Negative x over 4. So what's the next term in this series? Negative 3x over 4. All right. What's the next term in this series? Plus 3x squared over 16. Good. All right. Next one, positive or negative? Negative. Looks like 3 is staying. How many x's? X cubed. How are your powers of 4? Nice. All right. There's my 4 non-zero. Let's now do our general term. When we think about the general term, the easiest way to write it is just our first term times our ratio to our power, because we're starting at n equals 0. So I have 3 times negative x over 4 to the n. So what we're going to do, hopefully that wasn't too terrible. We will practice a lot with this next time because it's a really cool way to do these questions. I like the algebra in it. What I am going to do to prepare for next time is I'm going to try to shorten these notes as much as I possibly can. So we may not do all of the questions in here because I want to give you as much time as humanly possible to work on your problem set during class next time. I actually need to look at my schedule because it's messed up right now. So I will have a definite date for you next class, but I believe no earlier than a week from this coming Monday. So no earlier than that. I'm toying around with a couple of ideas. It will definitely be due before spring break, but in sometime in that last week. A reminder for this Unit 9 test, we will be taking it before we go to spring break, just because I know it will not go well if we take it after spring break. And I know as much as we would like to delay it, it's going to be not as fun if we do it after. But that
Master test.
no tennis.
Oh.
This one this is an important this is an important one. There's a whole free response on the AP test on this usually. So I will try to make the test as accessible as possible and be as helpful as possible. It's just hard content. You guys are in the hard part of calculus. So to be clear, that test will happen before spring break. And even if you're absent, I would highly recommend trying to get at least your round 1 done before spring break. This is not something you want to like ponder on over spring break. But that test grade will definitely be going on 4th quarter. Because of you seniors leaving for outreach, we need to shove some grades on that 4th quarter. So we'll take it before spring break. That's definitely on 4th quarter though. So your job, bring your problem sets next class. So as soon as you leave for outreach, you are done in my class, essentially. I am not, and your other teachers are not allowed to assign you things either. So what a lot of the senior teachers are doing is pulling stuff that would kind of take place in the 3rd quarter and putting those grades on 4th. For us, we're going to have 2 test grades. We'll have Unit 10 as well. And then I'm going to grade very leniently a lot of your AP practice. So we'll almost have like 3 big test grades, really. Any other questions? Ma'am.
So round 2.
I'm trying to get everything done before spring break. We should be able to do that very, very easily. Just if you happen to be absent, I would just try to make sure you get that in before, like at least round 1 before spring break. All right, we good? All right, last thing, I know that was so much content. I really appreciate you guys participating, being engaged and involved. Makes my job easier, so thank you very much. And I will see you next time. Enjoy your last few minutes of class just to rest your brain.
Don't tell me that was your last goal.
You could try taking some papers out of it.
Dude, she's not a